Well, welcome to our Structural Modeling Project video conference for June 2018. Today we're going to talk about value, truth, and utility theory, which is an interesting connection between the formal parts of the scientific process and the empirical parts of the scientific process. And I believe it's going to hold the keys to some concepts that will help us create a better understanding and therefore a better set of approaches to use for large group knowledge acquisition and large group decision making. So it's this particular month's technical report will be followed up with a more detailed report in July. So with that, let's just get started on it. Basically, the value and utility theory, value truth, are used mostly in economics and in large-scale economic theory. And economists have tried for a period of time to understand how people assign value and what is more valuable than something else, objects, processes, ideas, whatever, so that there's quite a bit of knowledge about how individuals psychologically and groups psychologically order value. This is more valuable than that. And so you place them in a rank strict order. So when we look at the techniques of systems engineering and system science, and especially looking at the structural modeling software, we find that we really had just examples of strict order or an example of clustering. So, and that other examples that we tried to reproduce and work with, we were unable to reproduce them. So we have a kind of a process where we're going to look at utility theory, we're going to look at the information about how humans really assign value and what are the axioms, what are the underlying assumptions that you have to make to be able to do that, and then see how that applies to our current activity of creating a structural modeling, an enhanced structural modeling approach. So utility theory basically is focused on evaluation of alternative choices of getting people to rate and rank things that ideas, processes, alternative actions as a group or as an individual. But it was found that people really have a very difficult time assigning a cardinal value of utility. They have a difficult time doing saying this utility has utility of 50, and this has utility of 10, and this has utility of 5. People really found that don't have the ability to do that. They do have the ability on the ordinal scale to say this is better than that, or that is more preferable. But they don't appear to have the ability to actually say how much better or how much less. They can just put them in rank order, put them in some type of strict order. So this area has been studied quite a bit since the late 1800s, early 1900s, and there's quite a body of literature on utility theory and how to approach it. And Hall and Metasystems methodology covers some of this work. Also, Austin it covers the idea of large-scale civil projects like highways, airports, or large-scale operational delivery like healthcare systems or educational systems. Talks about what are the assumptions and axioms behind utility theory and why it's important. And so we just list those here. These 5 primary assumptions are that the value aspects are comparable. And so that actually you would compare these, and there's a clear statement on the basis of comparison for the primary attribute. So if we were to say object A is bigger than object B, then is bigger than is what we're comparing them on. If we say, this investment strategy returns more dollars per year than that investment strategy, then the dollars per year is the basis of the comparison of the primary attribute. So pick a single attribute that allows either objects or processes or courses of action to be evaluated and compared. And then there's a quality of completeness. That is, the decision makers are willing to trade one choice for another. Decision makers can rank order all possible value positions, though some choices may have the same value position. So this gets into the idea that everything can be placed in rank order. Early on, there was quite a debate about values that could not be placed in utility theory. And religion is a classical example that people talk about. And the value of human life. So these are there are boundary conditions, and there's edge cases where humans and groups of humans really will not or don't feel comfortable about assigning a dollar value. In some cases, just for decision analysis and regulatory purposes, governments will assign values to like excess cancer deaths. So just as an example, you might say, if it costs more than $5 million of capital investment for a company to reduce one excess cancer death every 10 years, then that's too expensive. And what they're doing there is they're indirectly relating a human life to a dollar value, but they're also relating it to a process. So there's some cases in regulations where that does happen. And then number 3, it's possible to order all decisions. So essentially, in utility theory, you're making a decision about where things go in the order, and so it's possible to order them all, except the ones that are equal. And that's kind of implied in number 2, but the ones that are equal, we'll talk about that. And the implication in ordering and decision theory. And decisions are rational. That is, there's a strict order that may have more than one choice at a value position with no feedback loop. So that you have a single-threaded, directed acyclic graph with no feedback loop. And value decisions are independent of other types of judgments and decisions. So this is kind of the basis for the application of utility theory in economics. Now, Hall, when he goes through and talks about utility theory, talks about this idea of partial order. And so if some of the things on the list are incomparable by the ordering relationship, the remaining subsets of items that can be compared comprise what is called a partial order. And so this appears to be different than the mathematical definition of partial order. And it also is kind of seems to violate one of the primary aspects here, this quality of completeness, and that it's possible to order all decisions. So, I think what Hall is saying here is that you might be taking a subset of, or a component of your objects, and those you can use utility theory on, and those you can order, and then you have another group that you can't. So you're kind of applying utility theory to the ones that can be compared. But there's also, I think, another kind of more subtle aspect, not only in these actions, but also in this concept of partial order. And that's the fact that there are things that are comparable that can't be ordered, and those things are equal to each other. And I think that has been a source of a lot of confusion, and also a source of linguistic and conceptual misunderstanding in many cases. So that it seems that what you really need to do is you need to have an idea of things that are comparable and things that are orderable. And so things that you can compare and put in an order, that's one group, and things that you can compare that you can't put in an order because they're equal to each other, that's a different group. And that's what we've done with in our structural modeling approach with the clustering. We go through and we cluster things into groups. Classifications are the same, and then we order those classes. That's kind of how there's a strong connection there between the axioms and the approach and the current structural modeling approach. And then we have the idea of measurement scales. And these are interesting. And again, I think a source of a lot of confusion when you're translating from empirical data and observations through the value space to the formal space and back again. And we have a nominal scale, which is just where you use numbers as names. So where it says either A is equal to B or B is not equal to A. But that's just talking about the numbers. So if I pick the number 99, I have a race car number 99, I have a rock that I've painted 99 on, and I have a door that I painted 99 on. Those are all equal because they all have the name 99. It really has nothing to do with the object that the name is attached to. It's simply talking about the name. But if you have a name, let's say, for example, I can say car 99 went around the track 47 times in an hour. So that way you can use the name to attach frequencies to an object. But I can't say that the rock number 99 went around the racetrack, 47 times in an hour. This makes no sense. So the idea of nominalism and using numbers as names is the primary lowest level of the measurement scale. And then there's the ordinal scale. And this is the ordering that human beings can do. when we're talking about things are better or worse, you place things in order. But again, we have the idea of weak ordering and partial ordering, and those are addressed over here where it says ties are allowed. Again, we have, whoops, what we have here where ties are allowed. Well, I guess you can't just highlight the part, but we have ties are allowed, that means they're equal. And so we need to, and that's called weak ordering, he calls it here. So we need to actually make sure that we're very clear about what that means, that type of measurement. And again, in our case, we take and first cluster everything into classifications. If they're ties or if they're the same, we put them into a class, and then we order the classes so that there's a clear distinction. There's a clear distinction about what specific attributes and characteristics are associated with making them equal. And then there's a very clear distinction between and associated with how are the classes ordered? What do they do to order the class? So those things are very important. Then, of course, the cardinal, there's two types of cardinality, the cardinal scales, the interval and the ratio. And these are things that human beings are not good at doing, not good at making these types of judgments. However, in the systems engineering, systems science area, there have been people who have tried to use them. I think there was an example out of Stevens Institute where they did they took ordinal data from systems engineering experts, and then they went on to do matrix math and ratio and interval and many, many cardinal operations on the ordinal data. And of course, the experts from the NIST and the NDIA and from the government pointed out that this was simply an abuse of mathematics, and that you can't do cardinal operations on ordinal data. If you can do it, but if you do it, the output is mostly nonsense. And that's, of course, with papers written on that, they pointed out where the nonsense came up and why the logic was broken. So when you're working with groups of people and you're collecting ordinal data, then it's really important to understand the restrictions on the mathematical operations that are allowed on that fundamental empirical data. Okay, so the concept of a partial order seems to be the source of numerous conceptual issues and errors when reduced to practice. And I've run across this, a number of times where people have confused the idea of things being equal in a class and things being ordered. And there's a number of classical examples that I've said so many times that Barry wants me just to stop saying it. So I will just say in general, there's a lot of different ones out there. And that is where when you make this mistake, the output then becomes nonsense. And so the concepts of clustering and strict ordering applied in sequence cover the basic types of partial ordering used in structural modeling and utility theory. So if we do a sequence of these activities where we're discovering an unknown system and we're in the discovery mode in systems, and we first do clustering and then do strict ordering, you don't have to address the idea of partial order. But there's, again, I think there's more subtle and powerful types of concepts going on here. And that's, first of all, if you split these into two groups, right, the concept of clustering, you can cluster and classify objects on a wide range of characteristics and attributes. And then once you have these clusters and classifications, then you can order them. And then the ordering is done only on one attribute or one characteristic. So the cluster, if you use these techniques in series, then the clustering concept can be much more powerful and rich than if you're just saying, well, A is greater than B, and B is greater than A, so therefore they must be equal. And it also sidesteps the fact that if you use an asymmetric type of relationship, A is greater than B and B is greater than A, what you do is when you say they're equal, then you translate to a symmetric relationship. So the whole logic foundation changes. By separating them into the concepts of clustering, not only do we have a much more powerful clustering technique, but we completely eliminate the use or the translation in the same equation of going from asymmetric logical relationship to a symmetric logical relationship. So we don't have to address that at all because we don't make that transform, that logical transition in our computation. So anyway, that's one, I think one of the major takeaways from this specific utility and measurement activity is that the separation of cluster and strict ordering. And then there's another one where it really shows that the strong connection between utility theory process and structural modeling process. It shows that humans are not capable of assigning these cardinal values, which we've talked about before. An ability of humans to effectively order two objects, right, opens the door to the production and application of software systems that help one or more people effectively order a set of objects. So if we're in the ordering process, and because humans have difficulty with cardinal assignment, then it's very important to make sure that you cover all of the combinations and all the permutations. So within the GMU ISM software, when they do the ordering, when they do the strict ordering, they use the logic to reduce the number of comparisons that you have to do, but still be assured that you've actually covered everything in the space. So that greatly reduces the resource need. They do a similar logical operation on the clustering and classification. It's just that the logical operation is different. It's not ordered, it's grouped. So when we're looking, and Marion, so in our previous technical reports, we've talked about these in different ways. We've talked about these basically as a global type of characteristic for the strict ordering. We've talked, and the clustering, we've talked about it as a local characteristic for behavioral-based type of relationships. Done a number of these, and it's and I went back and I'm looking and comparing the characteristics that we've outlined to the natural language relationships, and they're starting to make clear effective associations between and saying basically the same output each time. And so that in the value truth, of course, we have a central role in the scientific process because it connects, right? It connects the formal logic to our empirical data. And so we want to do what is the most valuable in every case. And when we're doing this, the additional primary assumptions are found in utility theory. There are two basic types of utility evaluation: cardinal utility and ordinal. And of course, the cardinal utility was based on an assumption that turned out to be false. And when you look at this, this kind of relates, again, I believe, to some of the work that was done by Kevin when he's talking about requisite evolution of observations and your erroneous priorities effect. I think it has some effect. I think there's other aspects at play, but the idea of being able to vote on something and a number of votes without relating them to each other, I think might be one of the components that's associated with these two laws that Kevin articulated. As we said before, ordinal utility theory ranks preferences on the ordinal scale and indicates which is preferred choice, but gives no indication of the magnitude of the preference. So this appears to be what humans can do. They can do these, but they can say that this is better than that, but they have a difficult time saying how much. And when you get a lot of objects involved, 10, 20, 30, then the ability to assign any type of magnitude is almost non-existent. So given this, the key considerations for system science is to determine which basic types of system science activity to deploy. And there's kind of two distinct modes of systems activity. One is system discovery mode, and the other is system design mode. And the science of generic design and discovering an unknown system is obviously, the discovering an unknown system is obviously in the system discovery mode. There's some parts of the aspects of science of generic design which apply to system design mode. But mostly, the activities we've been talking about are discovering an unknown system. And they're fundamentally different. They have different value systems and they have different metrics. So structural modeling focuses on the discovery of an existing but unknown system structure, and system design focus on designing a system that basically displays the specified system's capabilities. Okay. Now, one of the things that we put in the example here of Kepler discovering the relationship that precisely described the laws of motion for our solar system. That's the discovery mode. And then Kennedy's direction to place a man on the moon by the end of the decade and create a large-scale design system to achieve that relationship. So we start to articulate the differences in the behaviors and motivations for these different approaches. And then, along with utility theory and value, they brought in the idea of regulated monopolies. And regulated monopolies are sometimes called utilities. So there's a little bit of overloading of the term utility here. But what we're trying to talk about is that there are certain situations where the socially optimal price is achievable only in a regulated environment. And that connects to systems and science and systems engineering when we're talking about, well, how would we design those, how would we discover what principles we should use to design a socially optimal price delivery system. So these are aspects that are associated with capital investment, adaptability, and encouragement and benefit to a society to act in certain ways. So we've introduced this here because we'll be using this a bit more in the future to discuss and evaluate and rank some of our future activities. Okay, so structural modeling activities, of course, have the two primary components: a group of people and the process used to manage and guide the group of people. And in the classical GNU ISM software, the computer-based software was really just a system logic unit that was directing the flow of group activity. And the natural language relationship that's used that creates a single-threaded ordered system. This is what we call the global characteristic or the global attribute, the past. Which, if you have a single-threaded, totally ordered system, the outcome is consistently reproducible. If you don't have that, then our experience has been is when we went back and tried to reproduce the previously published activities with the information available, we were unable to reproduce those. We got a different outcome. So that the outcome could be variable based on certain aspects of the mathematics implementation and other ways that people have implemented that logic unit. So most of those are closed source, so we really don't know what they are. One of the reasons that we're doing an open source piece is so we can have a detailed discussion about this and determine whether or not it's if a system gives us non-deterministic types of outputs, is that non-deterministic output based on software processes, or is it based on group learning? Because group learning is non-deterministic. And so there's in these large-scale processes and projects, what you really want to do, and what's good to know is that if you're getting non-deterministic outputs, that the source of that non-determinism is not the mathematics, but it's the learning and the interaction within the group that's doing that. So we've started to rate and rank the structural modeling activity value range, starting with 1 is what we believe the most valuable, and then going to 7 at this time, which we believe is least valuable. This is just a very preliminary chart. We're going to expand this, add more process steps and more definition to this. But this is just to introduce the idea. And the idea is we believe the most valuable part of this activity is the focus group learning and the focus group discussion. And that's where the real value lies. And that the computer support and the information management and the knowledge management activities that go around that, those are activities that are used to increase the efficiency of the focus group discussion, and without, introducing, let's say, spurious types of artifacts within the process. We started with this, just basically made it into 3 primary categories: provide computer-based logical support. So computer-based logical support, what we're looking at here is a strict order type of relationship. That's the GNU ISM, and our software basically has a mode that supports an ordered relationship. And the non-ordered relationship, of course, is something that's not clear, because a classification is non-ordered. You can't place things that are equal in an order. We will be expanding this and making it more distinct what we're talking about, what these relationships are. And of course, a non-ordered relationship would be like a behavior relationship. Like A causes B, things like that. And then we have create common context and learning support. I think this is one thing that wasn't available in the GMU ISM software. It was talked about in the specification, that it was really needed. And with the advance of computer science and computer processing and communications, this is an area where I believe a lot of benefit can be applied in the structural modeling activity, no matter what the relationship is, whether it's behavioral, ordered, equal. It really, I think there's a tremendous amount of potential in this center column to support focus group learning discussion. So basically, as it sits right now, what we've said is we start with an ordered relationship. We have group learning support, which can be pre-meeting, someone organizes the information. You have a computing system that goes through and analyzes all of the activities and connections between the people, picks the right people in subgroups and asks them questions, or gets feedback from them, maybe schedule some small pre-meetings before the focus group discussion itself happens. We believe that that is probably generates the most value. And then we believe the least value is basically ad hoc group discussions where people just think Barney Rice used to say BOTSAT. That's a bunch of people sitting around the table. We just, everybody kind of gets together in an ad hoc fashion, sits down, chats a bit, takes some notes, and walks away. So that happens a lot, and there's a lot of information loss, and there's no way to really say or determine whether or not everything has been covered that needs to be covered. So between BOTSAT, which is just an ad hoc group discussion, and a highly ordered focus group discussion that has a tremendous amount of context and learning support, there are many different variations. In our next technical report, we're going to introduce a preliminary type of conceptual architecture for this. We'll talk about what functions might be in each one of these boxes, and then start talking about what type of software is available to help, how it can be integrated, and go forward from there. So let's see. So anyway, the system relationship used in combination with a computer program guides the group discussion. And that basically is just to keep people focused. And if it's available, use logic to actually only ask for the information, the empirical information and data that's necessary, and infer all of the other information that can be given the logical situation. So group learning support activities, of course, prior to group discussions. And this is also another aspect, and I think Kevin has much more experience in this than I do. But there's an idea that basically you wouldn't have just one major event or a series of major events. Actually, that you would take a large organization like the Department of the Government or a large corporation, and you would build these activities into their management corporate structure or government structure so that they were going on all the time. So, well, what would that look like? And so one of the things, let's say in the learning support area, you'd have things going on in the background all the time, like essentially you'd have background computer analysis. So you, of course, you have to have the hardware and software But today the computing power is very cheap, and these types of activities for natural language relationships, digging out the connections and conceptual graphs and those types of things, they're available from a number of areas. And so these are things that could be part of the learning support and conceptual support that are very cost effective. And that would be going on all the time. And in focus group discussions, those can happen in, around different points of view. But then you need, at some point in time, you need to have, bring the larger groups together. Just having some type of process that determines, well, who should be there, how long, why should, and what focus, what types of people, and how, and if there's more than one issue, should we bring them all together in one big room? Should we have pre-meetings first and then bring them together, or what? That type of architecture, I think, is also important because each one has a different learning capability, and there's also a way to do learning support for that. I think those are most of the things that are talked about here. These idea of focus group discussions has the capability to add value. And some groups use non-ordered structured relationships. Some groups don't use say they do ISM, but they don't use the computer logical component. I think some of the fellows in India do that. When I look at that, that's kind of an interesting hybrid type of approach, because it seems to me that they're doing public policy design. And so they're really not discovering an unknown system. They're kind of, somehow they've determined what that unknown system is, and they may use some aspects of ISM to do that. It seems like they have a hybrid approach. But the output is some type of design process, so that it's important, I believe, also to make a clear distinction between the discovery mode and the design mode, because they're completely different activities, and they're completely different types of logical and information-based group activity. And so we see that there has historically that there's people that kind of do a range of these things, and they all believe that they add value. And I would have to agree that if they believe it adds value and it's important to them, then they're right, because they're the ones that are basically make that determination. Could the value be optimized? Could larger problems and larger types of activities be analyzed and engaged using different methods? Well, those are the things that we really need to look at in the future. And so realistically, what we're doing is we're setting the stage, starting to set the stage now to look at different processes, different types of software logical units, different types of software knowledge-based acquisition and human support activities. Look at a general architecture, look at what specifically might happen, what might be needed in those cases. So, in essence, what we're saying is the truth values and the value state and your value scale really, it drives what most groups and individuals do, and that the value truth setting between the formal logic and the empirical, or the formal space and the empirical space, is a good way to model and present a format within which we can discuss various different configurations and the value of those different configurations. One of the primary takeaways from this is that we really need to have a modular group of structural modeling techniques that's adaptive and clear which types of techniques you use in which case. So that means that basically you need a modular type of composable system software approach, and that's going to be some of the next things that we start working on. And that then is the overview. So any questions, comments, or concerns? Everyone went to sleep.
No, it's very good summary, and the research and efforts in utility theory is a fruitful way to get at these issues about ordering that you've been concerned with all along. The partial ordering, I'd like to see more. Maybe I'll put more thought into how your global-local distinction, if Hall had been using that, what would he have been able to add to his taxonomy? Because I think that's helpful. The idea of the numeraire, the single numeraire, is central to most decision analysis, of course, and that's sort of a global numeraire. Everything could be expressed in terms of dollars.
Right. Utils.
Right. Or expected monetary value. Right.
Right.
So the collection of issues there, the strict, the non-strict, and the partial are confused everywhere, but they're very closely related. But it's good to be disentangling that issue. I wonder though. I was trying to think of an example of a standard tree hierarchy. Are the elements on different branches, on different, what is it that you call them, threads, or different paths, or
so that's really a good question, Janet, and I'm going to try to ask a couple of questions so that I make sure that I understand what you're saying. And so when you say there's a tree and there's threads, so we have the objects, and then they're connected, they're related, connected by their relationship.
Mm-hmm.
And so the thread basically goes from object A to object B to object C to object D. That's essentially, I have a single thread if it goes through there, connects them all together. Right. And that's an order. And so now let's just stop just a second here, because there's something that I didn't really emphasize, and I think it's important. And the mathematics that Warfield published almost always started with a completed matrix of some kind. That was populated. Okay. And so all of those matrix approaches that he published work on a matrix that's populated. What we're talking about here is how do we go from zero? We know it's unknown. The matrix is not populated. The matrix has zeros in it. So now we're going from a zero matrix to a populated matrix. And so that the techniques that we're talking about now are just how do we develop this first populated matrix. After the matrix is populated and everybody's comfortable with that structure, then there's many techniques that you can apply. Okay, so I wanted to say that because I noticed that I didn't put it in the report. I'll make sure to get it into the next one. So yes, the idea of a single thread creating an order, whereas let's say a causal relationship, like a causal loop diagram, right? That creates a network, right? And then you can also have asymmetric trees.
Right. So that's the one I was wondering about, the asymmetric trees.
Okay.
Yeah, so speak about that. Yeah.
Well, so an asymmetric tree is not a it is not a single thread. There are multiple threads, and you have multiple entry points, and you can have multiple exit points. One of the primary issues with that is once the matrix is populated, once you have a matrix that represents your tree, your asymmetric tree, then you can analyze that matrix and say, oh, this is the first stage, this is the second stage, this is the third stage, this is the fourth stage, where these, and you can say, or you can look at them in stages, you can look at them in phases, and Warfield in his books talks about that. And so what that does then is it gets it maps a concept of linear time, which is single threaded, over these trees that have already been completed, right? So if I have a matrix that's already been completed, then I can say, oh, these things happen in the first stage. These things happen in the second stage, but they're not all in a single thread. You are relating that tree to the thread. And I think curriculum development, the curriculum structural type is one that I've struggled with a lot in that particular case, because that's almost two phases going on there. Mm-hmm. And I started looking at the documentation of these activities, and in many cases they would just do, oh, we'll go through and we've classified everything. They didn't do any ordering at all in their first event, right? They just said, what's same and what's different. That was event one. Then event two, they'll get together and they'll talk about, and then they'll order things. So that, and then as I started looking at it, I said, well, okay, that makes sense, because in the classification of same and different, they're using a much richer set of characteristics than they are to order them, right?
Right.
And so that, and then it also has the benefit of eliminating the issues with partial ordering. So, yeah, these aspects that you're talking about are very important. And if you notice in the work that Mary and I have published, we have dodged those questions. And we have just stayed at the core pieces, right? Because and so we wanted to develop these core pieces to a point where we can do what we're going to do next, which is, okay, do the abstract conceptual process, right?
Right.
And what do you do first? Well, first you got to get some kind of system structure. Okay, now that I have a complete matrix, then what can I do, right? What kind of values, what kind of information do I have? Should I use a lot? I need a lot of characteristics? Do I just need one? Those types of things. You can ask those questions and then move forward. So, yeah, those are really good questions, though, Janet.
This is all very exciting. It's interesting to see it slowly, one thread after another keeps getting picked up again and elaborated. It's very good. We have to run, so I'm sorry I
Okay,
can't
that's
finish the
okay.
slide, but we probably will be on if Kevin's going to have a session in 2 weeks.
Okay, good. Are you going to have a
So,
session, Kevin?
Yeah, we'll do one.
Cool.
okay. Okay, looking forward to it. Thanks.
All right, thanks,
Bye-bye.
Janet. Well, Kevin, any comments, questions?
I was curious about the comments you had about ratio scales. You didn't talk too much about it, but it was in the paper.
Yeah.
And I was thinking of the work of Zadeh and Satie in analytic hierarchy process, and Zadeh's fuzzy logic theory, or
Yeah, right.
the use of linguistic scales to produce ratio scales. And
Right.
I thought they had studies that showed that when you work with ratio scales, especially across a group, that they achieved a pretty good accuracy for things that existed but were not known. Like, for example, one of the simple examples I think Satie presents is like he has a bunch of shapes on the page: a circle, a triangle, a square, and he presents you with 9-level linguistic comparison, like shape A is greater than B, much greater than B, absolutely greater than B, something like that.
Right.
And when you do that across all the shapes, you average it across all the groups, it comes up with a very close to the comparison of the actual areas of the shapes, without trying to say what the actual area of any particular shape is.
Right. So with Setti's method, there's a couple of issues that people have tried to address. And first of all, they're non-transitive, right? They can be either transitive or intransitive or non-transitive, both. Okay, so there's some problem in the ratio scale itself, and then the mathematics. When you do the mathematical operations on them, there's issues with composability. So that if I have, a problem at the highest level, and I break it down 3 or 4 levels, and each one of those levels, I do a Satie matrix on them. The composability and ratio scales across those create problems. So there definitely are issues with that, but essentially, I think that there are cases where Setti's method might have some value, and it may be a type of module that we want to develop and place so that people can make it available. But I know there's specific cases and specific configurations where it is simply does not produce rational output. So we have to know where those things are. But yeah, there's a lot of tools, a lot of tool sets that you can actually use if you know what their constraints are. And I think that's kind of maybe the next phase we'll be going into.
Yeah, I had come across some articles a long time ago where it was suggesting to first do an ordering of things before you apply Zadeh's method.
Ah, okay, that's interesting.
right? So because it makes the once you get to ordering, you're so it's a multi-pass process. You first do the ordering, then you do the refinement with Zade's stuff. But for things like measuring risk, right? You don't risk risk is not something that exists as a number that you're discovering, like the comparison of the areas of different shapes. It's very subjectively evaluated.
Right. So and so there's a conceptual range, right? And so and 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 utility theory and risk management, when you're basically then mapping those techniques to map the risk tolerance of a decision maker using utility theory, I'm sure you're aware of, and all that. So that there's rich tool sets already available that can basically be applied here. And that's kind of what I'm saying, that the logical piece is missing out of many of these other approaches. But the logical piece, as far as I can tell, only fits a certain class of relationships. It doesn't fit them all. And so there's ways to sequence these that will give us a better outcome, I believe, than essentially just doing one thing and applying it to everything.
Yeah.
So yeah, no, I was kind of excited about coming up with this insight. It just kind of dawned on me one day. I said, "Oh, okay, good. I now see the pathway forward," because I was really struggling with how to bring in behavior, system thinking, systems dynamics, right? And how that works. And I think I now have a fuzzy vision on maybe how that might be done.
Oh, congratulations.
Yeah, maybe. Now I was going to see if I could do it.
Right.
I won't be bored for a few days anyway. So what would you like to do on 2 weeks from now? That's going to be the 16th, right?
Yeah. Well, I'd like to go more into the playbook and maybe tie some of what you're talking about with aspects of that, like for example, utility. One of the comments I was going to add to is utility theory presumes that the individuals have fixed preferences amongst sets of things.
Yep.
And that what you're trying to do is reveal them.
Yep.
And in structured dialogue, the preferences shift, and they shift through the dialogue.
Right. That's the non-deterministic point that I was trying. Yeah. I guess I didn't make it very well. Yeah, right. Though you're absolutely right.
They shift through the dialogue, and there's emerging. This is the past some years. Work by they're like a mix of. They're like logicians doing political science, or because they're concerned with voting systems.
Sure.
But they're real mathematicians and logicians, and they're now dealing with shifting preferences.
Right.
So I think that's an interesting. I've been trying to follow it, but a lot of it is the math and the logic is beyond my ability.
Well, I think that there's ways to address all of these things so that people can grasp it, because one of the issues I have is that if people can't understand that, it's not any good. You have to be able to understand what the processes are, right?
Yeah.
It's like, like, because if you don't, if you just have faith in what the expert says, then you're going to have faith in, things that are totally irrational, because that's what the mathematics say. So
Yeah.
that we need, in my belief, we need to stick to processes that people understand, because people are sensors. They're the source of the information, and they have to understand how it's being aggregated with the feedback. So that's great. Well, I think basically what I'm do is wrap this up, and we'll look forward to the June 16th further discussion of the playbook.
Okay, bye-bye.
All right, take care.